All right. Welcome in. So we are moving ahead with quadratic equations and what can we do with those. So welcome everybody. Good to see people still showing up and stuff. I know it's tiring at the end of the semester, and it's going to be especially hard after the break, after you get a couple days off to come back and sort of hit the ground running. But we're going to have to hit the ground running when we get back. So just make sure you're kind of ready for that. Okay, moving along with quadratic equations. So we looked at the square root property, which is the foundation of the entire chapter, right? I've said this before. You take away the square root property, this whole chapter disappears, even though it's the most forgotten thing from this chapter. Most people remember completing the square. Most people remember quadratic formula. But in a couple of weeks, for most of the time, when you tell to a student, oh, the square root property, they go, what? What are you talking about? So just remember, the square root property is the thing that makes this whole chapter work. It's like you could argue it's the most important thing in the chapter. It's not the most used thing in the chapter, but if you take the square root property away, you don't have completing the square. You take completing the square away, you don't have quadratic formula. So it's really the foundation of this entire chapter. And the square root property comes up, you should probably remember that. I see students struggle with this, like say in my applied calculus class when I teach that, or pre-calc or something. I'll have students who forget, and they're like, how can I solve this equation? I can't get it factored. And I'll say, well, you have the square root property or the completing the square or quadratic formula. And they go, oh, okay, I remember quadratic formula. I'm going to do that. But sometimes some of these problems that, yes, you can solve with completing this or quadratic formula, sometimes you can do in like a couple lines if you do the square root property. But it's unfortunate, right? It's one of those situations where, like students will ask, this is kind of the famous question, when am I ever going to use this? Well, the reality is if you forget math or you don't know it, you're not going to use it, right? But if you do remember it, sometimes it's going to save you a lot of work, or you'll just, sometimes you'll be able to solve certain problems like quadratic formula. People go, when am I ever going to use this thing? And then they get to applied calculus and they can't solve certain equations because they don't remember the quadratic formula. So it's a good idea to know all three of those pieces. Square root property, completing the square, quadratic formula. So notice how, remember we started with the square root property and said this is really convenient, but sometimes we run across in a quadratic equation that I have trouble applying the square root property. So we constructed this concept of completing the square. Completing the square is where you take a problem and you figure out how to do it in, you figure out how to put it in the right form so that you can use the square root property. That's all completing the square is you're algebraically manipulating the equation so that then it looks like the square root property, right? And that's a lot of what you do in calculus is you have a formula that you want to use. It's a calculus formula. And you're like, well, I want to use this, but the thing I have is not in the right format. It's not in the right form that I can apply this property, this calculus tool that I want to use. So then you do a bunch of algebra to manipulate that equation to get into the right place, right? I mean, I would say easily half of calculus is algebra. And I would say more than half of the people who fail calculus don't fail because of the calculus. They fail because they can't do all the algebra that's involved in setting up the calculus, right? So this becomes a more and more important tool of, okay, how do I algebraically manipulate this equation to put it in the form I want so that I can do a specific thing, right? And this kind of started back with lines, right? We were always trying to put lines in slope-intercept form. Why? Because that's the best way to use them. It's the easiest, cleanest way to have an equation. So we put them in that form because it makes our life easier. You do that same thing in calculus, and we're doing it here. Let's put things in the right form so that I can use the square root property. That's what completing the square is. Those of you who have done completing the square homework will realize it gets mind-numbingly boring, and the problems that are especially challenging because the fractions get really messy in it sometimes. You're just like, this sucks. These problems are not fun to do. Not that, most of you probably wouldn't call any of the problems we've done fun, but at least you kind of like move along. You can really get bogged down. Even if you're getting them right, you can get bogged down in these completing the square problems, and you're just kind of like, yuck, this is not like an exciting way to do things. But what you may have noticed is that it is also mind-numbingly boring. Almost every problem, like if you line up two separate problems where you applied completing the square, it's probably going to take the same amount of lines. You probably can match up line for line, like where you did the specific steps, because it's just the same thing again and again and again, right? You get the constant on one side, take half the x coefficient, square it, add that to both sides. Factor the left side. Use the square root property. Simplify. Like it's the same steps again and again. And that is both a strength and a weakness. The weakness is that we all hate completing the square because you're like, these problems, they suck. I just want to get them done so I can move on, right? So that's not great that they're not enjoyable, but that predictability that it's kind of the same thing every single time you do it also means we can come up with a shortcut. And that's what the quadratic formula is, right? People treat the quadratic formula like it's some big mysterious thing. All it is a shortcut for completing the square so that you get to those steps that people don't like where you take half the coefficients, square it, you end up with some messy fraction, and now you got fractions through the rest of the problems. People hate that, right? Well, the quadratic formula somewhat allows you to skip those worst steps. Now, that doesn't mean the quadratic formula is easy or quick, because it's not. You're still going to have plenty of simplification going on that you're doing. But most people prefer the work of the shortcut, quote unquote shortcut, because it may actually not be any shorter. But most people prefer those steps to the completing the square steps. Okay, so where does the quadratic formula come from? Actually, you could all create the quadratic formula. I think a lot of times people treat that, sometimes people have almost a fear of formulas and stuff like that, where it's, this was discovered by some nerd in a lab that never goes out and never does anything. And, they came up with this formula and now we all just use it. But a lot of formulas are a lot more accessible than most math students think. The quadratic formula is one of those. Okay, everyone in here who's done a few of those completing the square problems, you might find it challenging, but you could work through and derive the quadratic formula. You could make that, okay? Because, and I'll show you how in just a second. So it's not some, mysterious formula that a monk figured out on a hill somewhere after not eating for a week, and then they had a revelation and came up with this formula. It's not like that. Like, you literally could sit down and figure out where this formula comes from. And it's not a bad exercise to do because it takes away the mystery of this thing. Instead of being fearful and, this formula that you're intimidated by, and you revere the formula and, ooh, this quadratic formula, when you've derived it yourself, you're like, oh, it's not a big deal. I was able to derive it, so, how bad could it be, right? And then you understand it a little bit better, and you've removed some of that intimidation of math and so on. So here's all you do to come up with the quadratic formula. Instead of applying completing the square to a specific problem, like hopefully you've done some homework, you were doing problems that may be like 3x squared plus 5x plus 7 equals 0. Well, all we do here is we say, what about, instead of putting specific numbers in here, what if I just put placeholders for the numbers and chose them to be A, B, and C? And the A, B, and C can stand for any numbers, right? Any number you want, you could stick in there for A, B, and C. So this is the generalized form of a quadratic equation. So basically, that's where the quadratic formula comes from, is you apply completing the square, not to a specific problem with specific numbers, like you've been doing on the homework. You apply completing the square to this thing right here, ax squared plus bx plus c. Now, does it get a little, and it's basically the same steps, you're just completing the square. Does it get a little bit more complicated than the problems you've been doing? Yes, because in the problems you've been doing, there probably were simplifications along the way that you could make. In this case, when we're dealing with these placeholder variables, you can't really simplify because you don't know, well, if b over a was 4 over 2, you could simplify that to 2. But if b can be any number and a can be any number, we can't simplify that. So basically, it starts to look kind of scary, but that's just because we can't simplify along the way. But it's literally the same steps that you've been doing, right? So, like, what have we done here? Well, divide both sides by a. Okay, so then you get x squared plus b over ax plus c over a. All we've done, that looks scary, but all we did was divide by a. Okay, now the next step. Okay, we put the constant on the right side. We were doing that when we were doing and completing the square. And then look what they do here. B divided by 2a squared gets added to both sides. You go, wait, that seems different. Nope. B over a is the b over a is the coefficient on x. So remember we said take 1/2 the coefficient on x and square it? Well, that's just b over 2a squared. So they're doing the same exact steps that we did from completing the square. They're just doing it to a general quadratic. So if you finish that whole process, and yeah, it gets a little messy, but when you get to the end, once you've simplified everything, you get what we call the quadratic formula. It is a formula that gives us the solutions to any quadratic equation without having to actually go through and do completing the square the whole time. You could do completing the square. You can, in fact, if you couldn't, then this wouldn't work because this is just sort of skipping some of the scratch work for completing the square. So given a quadratic equation, any quadratic equation, you have two choices to solve it. You can use completing the square or you can use quadratic formula. They are both completely legitimate ways of finishing the problem. They are totally legitimate ways to do it. They both work. They're both fine. They're both important to know. Quadratic formula is important to know because most people, given the choice, will use the quadratic formula over completing the square. But like I mentioned, completing the square comes up in conics, conic sections, which you learned in algebra as well. Those are important. And you use completing the square there in a different way. So in that case, you don't get to choose between completing the square and quadratic formula. You just have to use the tools of quadratic formula because you're doing something different when you deal with those conics. So that's down the road. But you get this formula right here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, which sounds complicated, right? Couple things, you probably just want to have this formula memorized because it comes up so often in mathematics. You just should know it. Like I mentioned, when we're in my calculus class, applied calculus, and students are trying to solve an equation, they go, it's not factorable. Right. Try the quadratic formula. And they're like, oh, I don't remember it. How does that work? If you just memorize it, you'll end up using it quite a bit. Unless you're going to statistics, you won't really use it in there. But the rest of the classes, it comes up. This might seem like a big fancy formula. It's not too bad. One, this is not my preferred way of doing it, but if it works for you, go for it. You can go to YouTube and watch little like silly songs that'll help you memorize the formula. Good luck ever getting those songs back out of your head. But if that helps you, do it that way. The other way I think I mentioned in this class, I forget what formula it was, but you can learn any formula in 10 minutes, right? So what I would recommend is every time you do a problem, actually write down the formula. There's two reasons we do that. One, we write down the formula because it's how we're going to get through the problem. So why wouldn't you write it down? It's your roadmap through the problem. Write it down. And most of the time, students, by the time they finish the homework, they'll have memorized the formula because you wrote it down. Every time you did a problem, every time you used it, you wrote it down, and that's just going to help you memorize it. If you finish the homework and you go, I get it, but I still don't know the formula very well, just write this thing 25 times and say it while you're writing it. You go, what? You want me to write that 25 times? It'll take you 3 minutes. 4 minutes tops to write it 25 times. So do that. Say it while you're writing it, right? Go somewhere private so people don't like, what's that guy doing over there in the coffee shop? Is just like repeating the quadratic formula. What is he doing? Just if you get embarrassed about stuff, just go somewhere private, write it down, say it as you're writing it out. You will have this thing memorized inside of 5 minutes, okay? So don't worry about that. And then you can apply it. So let's take a look at how we would actually do the quadratic formula. Let's take a problem from the actual okay. Solve the roots in simplest form using the quadratic formula. So I think this one is actually factorable, but we're going to, again, it's about process. The important thing is not getting the answer right for a particular problem. What's important is understanding the process of how to do a particular problem. So x squared plus 64 equals negative 20x. Whoops, let's go over here. X squared plus 64 equals negative 20x. Was that what it was? X squared plus 64 equals negative 20x. Okay. So let's go back to the form that we want things in if we're going to apply. The whole quadratic formula is derived from something written in this form, where we identify the a is the coefficient on x squared, the b is the coefficient on x, and the c is your constant, okay, that's inside the problem. So, but notice that it has to be in this form where everything's on the left and then zero's on the right. That's how they have it set up here. So our problem right here, where we have terms, non-zero terms on both the left and the right, doesn't work. If you try to identify your A, B, and C from here, one of your signs will be off. And you might go, oh, that's just a small sign mistake. Your answer is going to be like completely off. It's not like it's going to be close to the right thing. It will just be completely wrong. So what we need to first do is get everything on one side. Basically, you're trying to write this equation in that standard form that you're used to. So add 20x to both sides. Oops. All right, add 24. Let's see, that's the problem, right? Yeah. Okay, so here we have our problem. So now we have it in the right form. We have 0 on the right side of the equation. We're all good to go. So let's identify. A is the coefficient on x squared. So A equals 1. B equals 20, and C equals 64. Right, and I'll see students where they're really good with actually doing the quadratic formula, but they'll forget this first step we did to get 0 on one side. They'll say A is 1, B is negative 20, and C is 64. And then it's just that one negative is enough to make the problem just be completely useless. And when you finally figure it out, you got to start over and do it all from scratch. So be careful about putting them in the right form first. Okay, so we have a quadratic formula, and that quadratic formula says that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Oops, that's not an a, that's a z. Okay, so there's our quadratic formula. So again, just see how I just wrote it down there? When you're doing these problems, doing the homework and the lesson and stuff, just write it down. If you write it down, 20 times or something, by the time you're done with the homework, most of you will know the formula. And you won't have to worry about, how am I going to learn the formula? You'll already know it because you've been using it. That's a good indication that you don't know the material well enough, is you haven't learned the formula. Okay, because it should just kind of happen as long as you're paying attention and sort of noticing the formula. If you keep writing it down and saying it when you write it down, you will get it. Okay, so now we start plugging things in. So let's see, x equals the fraction. These take me a little time to type up because they're so math heavy. Let's see, so we've got, so negative b is going to be negative 20. Then we've got plus or minus the square root of, okay, b squared. Now here's one thing I'll tell you. Don't try to simplify a bunch of stuff in one step. So see how I'm at the step where I'm transferring this over to, I'm just substituting the values in. What I see people do is they try to do 4 steps in this one place. So not only are they substituting things in, they're also simplifying a ton of stuff along the way. That is how you make mistakes. because your brain is just not designed to do two different math things at once. When you're really good at it, yeah, maybe your brain is ready for that. But when you're first learning these, if you try to do substituting at the same time that you're trying to do a bunch of simplifications, you are going to make a small mistake somewhere. And in these, a small mistake is the same as a big mistake because it's just wrong, right? So let's see, square root of, so b squared, so that's going to be 20 squared minus 4 times 1 times 64, which is c. So there's our negative b plus or minus the square root of b squared minus 4ac. And then the bottom is 2a, which is an easy one. That's just going to be over 2 times 1. So that. So notice I didn't simplify anything here, did I? All I did was substitute values in. When I'm grading papers, the people who just substitute in and then take more lines to simplify make less mistakes than the people that are trying to substitute and simplify at the same time. It's just too many things for your brain to keep track of. So don't do that. Okay, now we can look at simplifying. So let's see, x equals the fraction. So we've got negative 20. And even here, I'm not going to try to simplify this whole thing at once. I'm going to do little simplifications, move to the next line. Little simplifications, move to the next line. And just keep doing that. Writing is not that hard to do. It's not that much work that you're going to, you're going to be winded by the end of the problem. Just write stuff out. It's better than having to do the problem a second time. Let's see, plus or minus. Okay, so now we have to deal with the square root part. The thing inside the square root, you have a couple homework problems on this, is called the discriminant. The b squared minus 4ac part is called the discriminant because it's going to determine what types of problems or what types of solutions we get. If the thing inside the square root is negative, we're going to get some complex numbers, right? If the thing inside the square root is positive, we're going to get real number solutions. If the thing inside the square root is 0, then we get a repeated solution. So that's all that, when you get to the part about the discriminant, that's all that's saying is it's the part inside the square root, because that means that I don't have, if I want to know, are my solutions going to be complex numbers? I don't have to actually find the whole answer. I could just look at b squared minus 4ac and go, yeah, it's negative, so I'm going to get complex number solutions. That's convenient to know. So you'll have a couple homework problems like that. Okay, so 20 squared is what, 400 minus, okay, 4 times 64 should be, what, that's 256? So 256, I better get my calculator ready so I don't make some mistake trying to do this all in my head. Right, 16 times 4. 64 times 4. 256, right. So 400 minus 256 is 144. Okay. Oh, and this is all over 2, right? Okay, so see how it's starting to simplify down? That's good. We're not trying to do everything in one step. So x equals the fraction negative 20 plus or minus. Okay, so I'll just go ahead and write it. The square root, I keep telling you to write all out, so I don't want to skip too many steps. 144 all over 2. Oh, great. This is coming out real nice. Okay, here's a common mistake that I see at this point, and you just got to get it in your head not to do this. Someone will look at this and say, hey, look at all those numbers in there are even. Why don't I simplify by dividing everything by 2? We could divide 20 by 2. Okay. We could divide 2 by 2. Okay. Can we divide 144 by 2? No. Here's why we can't. That number sitting in our fraction is not 144. And you go, what are you talking about? I'm looking at it. It says 144 right there. Not really. It says the square root of 144. So we don't have 144 sitting in that numerator. It's the square root of 144, which is 12. It's really a 12 sitting there. So you cannot simplify a term that is still inside the square root without doing some simplification first. Okay, so just watch what I'm saying. Here, I'll say x equals the fraction negative 20 plus or minus 12 all over 2. Okay, now that we've gotten rid of the square root, now you can simplify things. Now, sometimes what I'll see people do, and this is wrong, is they'll just cancel the 2 out of like the 20 and the 2 right here. We can't do that. What about the 12? Why didn't you divide the 12 by 2? So as long as you divide all of these things by 2, then you can simplify it. Or you could take care of this plus or minus and then simplify afterwards. You have a little bit of choice about the order in which you're going to do some of these operations. But just make sure you're not trying to simplify and divide something that's inside of a square root. Just remind yourself, yeah, I know it says 144, but that's not really 144. It's the square root of 144, which is different than 144, right? So let's see. And then when they're in this form where they're easy to simplify, you should simplify them down to actual numbers. All right. If you end up with something like square root of 7, you're not going to be able to simplify that any further. Sometimes people think taking square root of 7 and putting it in a calculator and getting, let's see, what would we get? Getting 2.64577513106459059 and so on. They go, well, that seems really scientific. It's actually not. That's an approximation for square root of 7, whereas if you write square root of 7, that means exactly square root of 7. So don't convert things into decimals. It's usually not a good idea. Leave them as like square root of 7 and stuff like that, okay? So let's see, what's this going to be? This means that x equals okay, so negative 20 plus 12 is going to be negative 8. Negative 8 over 2 will be negative 4. So not even a fraction. That one just came out nice. And our other answer is x equals, let's see, if I subtract 20, I get negative 32. Negative 32 divided by 2 would be negative 16. Is that right? Yeah. So our answer should be negative 4 and negative 16. It's entirely possible that I messed something up because it's easy to make mistakes in these, and especially when you're talking while you're doing it and trying to teach people, it's easy to make a mistake, but let's see if I got it. So negative 4 and negative 16. Okay, I got it. So you can see, though, they did the same steps I did. You get 0 on one side of the equation. You identify your A, B, and C. You write down the quadratic formula. You plug everything in without simplifying. You just substitute stuff in. No simplifying yet. Then you go through and simplify. They're saying calculate the discriminant, but like you don't need to finish the problem. But you'll learn about the discriminant when you do some of the homework. Then they simplify stuff through here, get their answers, good to go. So that's how you do the quadratic formula. Not too bad. Most people would look at this and say, okay, it wasn't exactly like a one-liner because we have what? 1, 2, 3, 4, 5, 6, 7, 8. 8 steps that we did, but most people prefer this to completing the square. I prefer to completing the square. Just seems better this way, okay? So that's what you're going to do every time. Now, you're going to get different types of answers because, like I said, if you get a negative inside the square root, then you have to go back to the complex number section and go, oh, do I remember how to do complex numbers? Hopefully you do. Or what if this didn't simplify to a perfect integer when we took the square root? Now we're going to have irrational numbers in there. You got to deal with that. But that's just simplifying. So it's using the previous chapters. You did a chapter on simplifying roots. You did a chapter on complex numbers. Well, a section of a chapter on complex numbers. You've used all these tools. You've learned these tools. It's just that you need more of them going on at a single time. right? This is kind of the first chapter where it's like, okay, there's a bunch of new stuff in this chapter, plus I have to remember stuff from the previous like 2 or 3 chapters in order to put it all together. Yeah, that's just what it takes. And it's intimidating at first, but you know, it's like anything at life. You build up a tolerance to it and you get better at it. You get faster, you get more accurate, and then it's not quite so tedious, right? It's like when you first start running, if you haven't run for a few months and you go out for your first run and you just feel like you're dying, but then a couple weeks later, you're like, you know, barely breaking a sweat. It's the same thing here. You do these a little bit, and they catch on, and you go, okay, I see what's going on here. Okay, so let's see. There's a particular thing I'm looking for. This will do it. Okay. So I actually want to look at the solution of this. We don't need to go through the entire problem, but I want to point out a step that occurs here because almost always someone asks about it. So just remember in math, don't overthink something. If something has a formula, follow the rules for the formula. And it's okay to ask questions. That's fine. But what I'm trying to do is train people to not make up things to be concerned about that aren't really concerns. And in this case, it's the B value. People sometimes get confused about the B value. So here's what happened, right? We did some work to get 0 on one side, so we added 21 to both sides. Notice that our B value is -20. And then people sort of create this, and it's fine to ask the question. So I don't want to make anyone feel bad or anything if you were wondering this, but what I'm trying to get you to see is that you just follow the mathematics. Don't make up things to like throw you off the mathematics. Just follow the mathematics. So here's the question I'll get. Well, wait a minute. I'm confused because my B value is negative, but also the quadratic formula has a value -b in there. So then what do I do? And the answer is you follow the formula. Just do what the formula tells you to do. The formula says that you put a negative in front of your B, and then when you substitute your B in, you substitute in -20. So you have -20, right? Don't try to make up special cases. Just follow what the formula is telling you to do. So we end up with -20 here. Well, what is a -20? That's the same as +20, right? So you can see down here it becomes +20. So don't overthink this. You do have a -b in your formula. If your B is -20, just follow the directions and substitute it in. You'll end up with 2 negatives that cancel each other out. You'll end up with a +20 in front, or whatever the number is that you're dealing with for your particular problem. Okay? So, and then you kind of follow it out from here. Notice in this case, they're getting some fractions. That's actually a good scenario because some of the answers to these problems get really messy where you've got 2 plus or minus 3i square root of 7 or something like that, where you have not only something that has square roots in it, but also is a complex number. It's a lot of things to keep track of. One good thing about that is it's really going to force you to get good at those last few chapters. If you got through those last few chapters and you're like, I kind of get it, I was able to do the homework, but I'm still a little unsure about it, you're going to get sure about it because you're going to be dealing with those as you do these problems. So you will get better at them. Okay, so there's always that. Just don't let a -b value confuse you. It doesn't need to be confusing. Don't let it throw you off. Okay, let's go back. So see how you're going to have a few. Some are where you have rational solutions like we were just looking at. That means they can be written as a form of a fraction. We did one problem where we got integer values, -4, -16. We just looked at one where you got fractional values. That's okay. That's perfectly fine. You sometimes are going to get these irrational problems. I'm trying to watch the time and see what I have time to go over. And then your quadratic formula problem. So let's see. We've got... Oops, it looks like I've got this in 2 different assignments. That's okay. It's good for you to do some word problems. A lot of times there's like there's sort of a dislike of word problems. Okay, but the best way I've ever heard it summed up, I didn't say this, someone else said it. I don't remember where I heard it along the ways, but someone, some professor was talking and he said, look, everything's a word problem in real life. Okay, when you're first learning mathematics, we give you they sometimes refer to as naked problems. They're naked because they don't have anything attached to them. They're just exposed as an equation, right? But in the real world, no one ever does that. No one ever just finds a bunch of equations and decides to solve them, because most people don't do math as a hobby, right? The reality is, if you're doing math, you're doing it because you're about to buy a house or a car, or you're planning for retirement, or you're trying to decide about some kind of a purchase, or you're investing, or you're running a business and you're trying to run the financials of the business, or you're doing some research and you have some questions that you want to answer. None of those are ever just going to magically expose an equation and then you get to solve it. They're all word problems. They all are collections of information that you have to sort through and figure out, what am I going to do with this information? Okay, and you organize it and you work on it and you construct an equation and then you solve it. So yeah, I know people don't like word problems because they are more challenging, but at the same time, if you don't learn how to do word problems, then this entire class is a waste, because no one's ever going to come up to you at your job and say, here's an equation, solve this and get back to me. That's not what happens. They're going to dump a bunch of info on your desk and reports and data and say, find out how many parts we're supposed to buy next month. Oh, okay. And then you have to take what is essentially a massive word problem and solve it, right? So just don't let word problems intimidate you, right? Again, it's kind of like exercise. Again, the first time you go for a run, if you haven't run in 3-4 months, is like you're like dragging and you're like, I can't breathe. And then pretty quickly you're like, all right, this is easy again. Okay. So let's take a look at those just so you can find your way through it. So a company sells widgets. That's just a term they use in economics to just mean like it's almost like a variable. It's just a pretend thing that gets sold. So it doesn't matter if it's air conditioners or toy cars or television sets. A widget is just an imaginary thing being sold. A company sells widgets. The amount of profit Y made by the company is related to the selling price of each widget, X, by the given equation. Using this equation, find what price the widget should be sold for to the nearest cent for the company to make the maximum profit. Okay, so let me figure this out again. Where are we? Okay, where are we? So the amount of profit Y made by the company is related to the selling price for each widget X. Okay, so X. Okay, so see, it's even taken me a minute. This is what you got to do. You got to break it down and figure out what the pieces are. Okay, so X is the selling price. So we input a selling price into this equation for X. And then what we get out is the Y value, which is our profit. See how they tell me that? Sometimes I'll do this in class, and I'll say the thing I just said, and then a student will ask me, well, how did you know it was X and Y? How do you know which one's which? Well, you read it just like I did. You break it down. It says the amount of profit Y. Okay, so now I know Y represents profit, is related to the selling price of each widget X. Okay, now I know that the selling price is X. By the given equation, using this equation, find out the price the widget should be sold for to the nearest cent to maximize profit. We want to maximize profit. Okay, so that sounds good. If I'm running a business, maximizing profit sounds like a great idea. I like that idea. I'm going to maximize profit. Let's do that. Okay, well, here's what happens with let's see, I want to see if they show the graph and the solutions here. They do. Okay, so anytime you graph a quadratic function, you get this shape here, kind of a U shape, not like the letter U, kind of a U shape. And there's two possibilities. Either the thing is like this where it opens downward. See how at the bottom we've got these arrows shooting down? Or you can have a parabola this is called a parabola. You can have a parabolic shape that opens upwards. Okay, so it's either every quadratic equation you solve is either going to be a downward facing parabola or an upward facing parabola. And you can have lots of different parabolas. You can have really wide parabolas. Here, let's take a look in Desmos. So let's see, ax squared. Let's do it this way. X minus h squared plus k add all these in here and make it bold. So what is this form? That you can take a quadratic equation and put it in this form, but we're not going to get too into that. But watch this quadratic equation that or quadratic function that we're looking at here. So I can make it skinny or wide. See how it's opening up? Now it's opening down. So we can make a really skinny one, a really wide one. We can make it flip upside up, make it really skinny or wide. We can move it around so they're in different locations, right? There's all sorts of stuff we can do with this. So there's an infinite number of parabolas we can come up with. Every second degree polynomial, every quadratic equation graphs a parabola of some sort. Well, what's the interesting thing about a parabola? Well, an upward-facing parabola has a minimum right down here at the bottom, and a downward-facing parabola has a maximum right up here at the top. So if you have a downward-facing parabola, you can find the maximum. If you have an upward-facing parabola, you can find the minimum. Why would you want to minimize something? Well, maybe you want to minimize cost in your company. What's the way that we can have the cheapest cost? In this case, profit. What's the way that we can maximize profit, right? In other words, how many units do I have to sell to make the most profit? You might think, well, can't you always just make more profit by selling more units? Not necessarily. Business pricing gets very complicated in many situations. So it could be that sometimes you keep selling more product and you actually lose money by selling more. Well, you don't want to do that. If you can maximize your profit by selling 500 units, then you don't want to waste everybody's time selling 700 units because that's more time everyone spent, but also you're going to make less money. Why would you work harder to make less money? Probably shouldn't be in business if that's how you do things. Okay, so let's go back to the question. So they're asking us to maximize the profit. So we graph this function, and you can use Desmos or something like that to do that. We'll get more in-depth to graphing quadratics if you take college algebra or pre-calculus or something like that. We'll spend a lot more time graphing these. So you graph it. This thing has a maximum right here at what we call the vertex. Okay, so you could get this by graphing it. So let's see if I can. I don't think it's going to let me copy paste this, but let's try. If I go in here. And we can't see it. Why? Because we need to open up our graph a bit. So it goes, what, to 60 and then to 6,000. Okay. So I come over here to this, if you can't see it, on Desmos. This is a free website. You can use Desmos just like I'm using it. We'll come over here, and I'm going to adjust my x-axis and y-axis. So this is going to go to, say, 70. And then my y is going to go to 6,000. Oops, that's because this got messed up. There we go. Now we can see it. So see how now it looks like the thing. Let me get it right there. There. It looks like the thing here. Okay, so how do you figure out where that exact value is? There's a couple ways to do it. One of the ways we do it is you figure out negative b over 2a. So remember the a, b, and c that we used with the quadratic formula? Same idea. Negative b over 2a means that we would take, so b is 539, so negative 539 divided by 2a is going to be negative 16, so I'm going to go 16 sign change equals 36.33, and if we go over here, wait, did we get a different answer? Hold on, I gotta make sure I don't keep covering up. Why did I get that? Oh, there was a previous thing in there, so it becomes, I hadn't cleared it before. So looking at it, I hadn't cleared it, so let me try that again. So I'm gonna go, what was it? 539 divided by 2a would be negative 16, negative 33.68. So they just round that to, where did it go? Negative 33 or 33.69. Wait, why did I get a negative? And they Oh, because it's negative b over 2a. So I should have, yeah, my negative should have canceled out of there. So it should be 33.69. Okay, so that's where the x value comes from. It's that formula negative b over 2a. Where did this number come from? Well, we have the equation and we have an x value. So just plug your x value into here and you will get the y value. And then you'll get these, and then you know, okay, 33.69 is the best price that we can come up with in this case. So in this case, even though, yes, it's a word problem, they're still basically giving you the quadratic equation, right? It's not like you have to come up with the thing on your own. You can sort of figure out what it is. So not too bad. Okay, where are we in the... Oh, I'm looking at it. I was looking for the tab, but I'm already in there. Let's go back. See anything I can say before the weekend's out. So work on the word problems. The quadratic inequalities, just follow the videos. Just do what the videos say to do, and you should be fine. And try to make sense of the operations composition of functions. If a lot of people come with questions next week, we can spend some time looking at this. But remember, we only have so much time, and I can't cover every topic, so I kind of have to figure out what to cover. But if lots of people are asking me about these two topics, then I can address it on Monday, and then maybe we could bump those due dates out a couple days or something if people need it. But if I look and people have completed the homeworks, then we can move ahead, because I want to make sure we have enough stuff for inverses. We definitely need to spend a little bit of time on. And then this logarithm stuff, man, people get confused about logs. So we need to make sure we have plenty of time to talk about logarithms. I was confused the first time I learned logarithms. I remember I just memorized a bunch of stuff. And then later on, when logarithms kept coming up, I was just like, man, I don't get logarithms. What are we talking about? It's confusing. Okay? Definitely confusing. So that's where we're at. So anyone who wants to stick around and ask me questions in Zoom, feel free. Otherwise, I'll see you next week. Be safe this weekend, right? Lots of people coming together. COVID numbers are already spiking. Just be safe. Make sure that you're safe and that you don't, infect grandma or something like that. So enjoy yourself, stay safe, and I will see you next week. Okay, thanks everybody.